Howdy and welcome back. In this video, we're going to introduce function objects. I know they sound maybe a little bit involved, but what we're going to see here is they're going to be very straightforward to create. It's simply going to be the introduction of a new type of object, and we're going to provide an provide definition for the call operator for objects derived from our type. So function objects, let's get right into it here. A function object is going to be any type that implements the call operator, that is operator, open, close parentheses. By defining the call operator, what we're going to see here is we create callable objects. And the primary advantage is going to be that these objects can contain state. I'll show you an example of what I mean by that here shortly. Though what we will see, and kind of one of the trade-offs or disadvantages of creating function objects to have these callable objects that can be passed to high order functions, is going to be that there is some syntactic overhead of a class definition involved to create them. So creating a function object. To create a function object, we're going to create a type and define the call operator. Straightforward enough. So we're going to build up from our movie filter kind of example, and we're going to create a callable type called released before. Notice how this is getting away from our released before 1990 function that we defined in the previous example when we were, or I guess even previous lesson. But notice that that released before was, the date was actually kind of built into the function. And you might go, well, here, let's go up here. Um, here's our release before function. And you go, okay, well, that 1990 is kind of built in. And look, it's even hard coded, in the definition here of that function, its implementation. And you go, well, what if I wanted to, I don't know, change that to 1980 maybe, right? And you could go, okay, well, I mean, if we look at how we call this, an easy way to do that would be to just tack on an extra parameter, call it maybe release year, and use that parameter in the comparison. And then when we call this from our movie filters, it would be filter movie and then comma release year. But that gets away from this kind of generality that we're looking for, right? Because then every time we call filter movies, we're going to have to provide an additional argument that would get passed on kind of to this, filter function. And what we really want to do is kind of come up with a way that we could maybe contain the year, easily create new kind of filter functions in a manner that would allow us to store some sort of state, maybe the release year that the comparison is being performed on. And one additional thing I'll throw out while I'm kind of rambling off in the previous slides is that if you notice when we were introduced that copy if function, the function being passed to that standard library algorithm could only have one parameter, and the parameter was the type of object that would be used in the predicate operation, right? Returning true or false to tell you whether or not that specific object met the criteria that we were looking for to copy it into that, or I guess push it back into that filtered vector. So again, we're going to want to keep this general, and we're also going to want to define these functions in a way where, we can not only apply them to our filtered movie, to our functions that we could create, such as filtered movies, but also in a way that we have some sort of systematic way to create these to pass them to even the standard template library algorithms. So back here, class is going to be released before. That's the name of the type that we're creating. It's going to have a constructor, which is going to take in a single unsigned int parameter, and we're going to call it year. Where are we going with this? Well, if we go ahead and look at the private data members for objects of this type, we see one year. It's an unsigned int. And the initialization process, parameterized construction of release before, is going to go ahead and initialize the year data member with whatever was passed, whatever argument was passed to the parameter of the parameterized constructor. So at this point, we could, create new release before objects. So we could write released before, and let's say before, I don't know, 1990. And then because we don't have default construction, we only have parameterized construction, let's go ahead and pass in the year 1990. So before 1990 is an object of type released before whose year member is going to store the integer value of 1990. Now here's where things get cool. Let's assume we have that movies collection that we've been talking about, and let's so I know the structure of that collection's on the next slide. I don't want to jump to it, but let's just assume we have some sort of movie M. We could check whether or not a particular movie has a release date less than 1990 by invoking its call operator, which we have defined here. The call operator is going to return a Boolean value. Its name is operand open close parentheses call operator, and it takes a single movie object by reference to const. And well, since it doesn't mutate the underlying state of this, the appropriate postfix denotion that it is a constant member function has been provided here. Now, if we go ahead and look at its definition, it is going to return true if the movie passed to it has a release year less than release, which means when we invoke the call operator on this before 1990 object with some sort of movie, this function gets invoked. The state is preserved, here, and that year is actually a data member of the particular object. We could, and the cool thing about this is we could create a before 1980 and go ahead and so before, let me have this on a stand. This will make writing a little bit easier. So let's try again. So, but released before, let's say before 1980. So notice at this point, we've introduced two objects of type released before. One's named before 1990, one's named before 1998, or sorry, 1980. And the 1980 object has its year initialized to 1980. So now if you were to invoke before 1980 with some sort of movie object, this function object would return, this function invocation would return true if the movie object passed to it had a release year greater than the year stored in this object's year data member, which is 1980, and false otherwise. Similarly, for before 1990, if the movie object had a release year before the year stored in its private data member year, 1990, function would return true, false otherwise. So let's go ahead and look at this in action. So we're going to go ahead and, I mean, this is more legible than what I was writing. I like to get ahead of myself, as you all know. So release before 1990. So release before 1990 is a release before object whose year is going to be initialized with the parameter passed to this parameterized constructor, 1990. So let's go ahead and just look at kind of a simple loop here. Let's iterate through each movie within our collection of movies, which I have gone ahead and listed out here. So at index 0 of our movies collection, we have Citizen Kane. 1, we have Rear Window. 2, we have Pulp Fiction. So first movie that's going to get passed to our function object is going to be Citizen Kane. So we'll hit our definition of its call operator, and we're going to return true if Citizen Kane has a release year less than 1990. And in this case, it does. So if we look at the body of our for statement here, we're printing out the title, the release year, and then the return value, if you will, of release before 1990 with its call operator past the particular movie under consideration, in this case, Citizen Kane. So looking at the output, we see 1. Okay, now we're at the next movie in the collection, Rear Window. Same thing happens, released before 1990's call operator invoked with Rear Window. We make that comparison, and 1954 is less than 1990. So it is going to return true as well. Now, the last movie object in this collection, Pulp Fiction, when it's passed to this release before objects uh, call operator, it's going to return false because 1994 is not less than 1990. So we can see there 110 was the results returned for Citizen Kane, Rear Window, Pulp Fiction, respectively. Now, just showing the utility of this and the implications of this, the fact that these objects can maintain state. Let's create release before 1950 and pass to the release before parameterized constructor, the integer value 1950, and then run through the similar operation, printing out for every movie in our collection of movies, the title, release year, and then whether or not that movie's release year is before, in this case, 1950. And we see here only Citizen Kane. When running through this iterative statement, do we see it have a 1 as the output or return value, excuse me, to symbolize true for release before 1950's call operator invoked with the movie. Okay, so now let's go ahead and transition into applying this kind of to that functional style programming that we're going towards, and that we want to be able to create a filter function that will allow us to pass a function object as so. So let's say we want to pass our filters movie function. So somewhere this is very declarative. We're simply asking for a collection of movies back. We pass it our collection of movies as defined or as laid out on the previous slide. And then let's pass it a function object. In this case, it's going to be a released before object who has its private data member year initialized with 1990. So notice this T release before. This is a call to the parameterized constructor, which will create a new release before object whose private data member is initialized with 1990. And that object will be the argument to our filter movies function, which will then be bound to the parameter T filter. So if we read this, here's how it kind of looks. Because again, the semantics of argument passing are identical to that of initialization. This is effectively communicating that T filter is going to be a released before object parameterized constructed with the integer value of 1990 as its argument. And if we go ahead and look at that, we know here at this point, well, T is going to be a release before type by template argument deduction in this case, etc. Okay, cool thing at this point is now when we hit this statement, filter movie. So what we're doing is we have, what is filter? Filter is a released before object. It's already been constructed, and when it was constructed, its private data member year was initialized with 1990. Now here, this call, so filter movie is invoking this operator, and the movie being passed to it, whoops, sorry, I got so much colors going on here. The movie passed to it will be used to initialize the movie parameter. And then under consideration is whether or not that movie has a release date less than the year or value stored within the year data member. In this case, first time through with Citizen Kane, that will be true. Second time through, that iterative statement with Rear Window, true. Third time through with Pulp Fiction, false. So the filter movies object that is returned here, it's a standard template library vector of movies, will contain the movies Citizen Kane and Rear Window. Because Pulp Fiction did not pass through the filtering process, it did not meet the filtering specifications, it was not pushed back to our filtered movies vector because the call operator for the filter release before object returned false. In the other two cases, it returned true, which meant that those videos or movies were included in the collection. So hopefully all these arrows are, kind of not disrupting the takeaway. Hopefully y'all kind of see what's going on here with these function objects. They're pretty cool because they're not only callable, but we can store different things in them. So as you begin thinking about that, since these are objects, they're constructed as such. We write a class definition from which they're derived. We could do a lot kind of more elaborate things if we wanted to do so than what we kind of could with an ordinary function, because with an ordinary function, it gets called, activation record pushed to the stack, returns. There's no kind of way to store some sort of state from call to call as we could in this process of kind of call to call within a function object, because the object that is callable actually has an underlying state, which we could actually store different things and kind of compose that state to our liking. So let me see where this is going. Okay, I think I added in this slide here a little bit prematurely. So let's go ahead and jump into our defining higher order functions. We're going to review the two kind of parameters needed for filter movies, function to accommodate function pointers versus that of function objects. And then we'll talk about the standard template library, function type, which allows or can handle both of these types of objects being passed to it. Well, pointer type and then function object type. So with that, see you in the next video here.